Um, Hello everyone, good evening. So here we shall solve some more KCET previous year questions on the chapter Redox Reactions. So any doubts if you have in any steps of the solutions, then please write that in the comments section. We shall obviously clarify those doubts in the subsequent videos. Also in any other chapter of chemistry, if you have more difficulty, then please mention the name of that chapter also in the comments section so that we can give more priority on it and solve more and more questions on that chapter. Also some important homework questions will be uploaded in the Sapience Education application. So please install our Sapience Education application, whose link has been provided in the description. So here in the first question it is told that when compared to delta G naught, which is called as the standard Gibbs free energy change. Standard Gibbs free energy change. Standard Gibbs free energy change. So this delta G naught for the formation of Al2O3, the delta G naught for the formation of Cr2O3 is, so it will be higher. Since why? Since suppose we take the reaction of Cr2O3 with Al, then it will form Al2O3 plus 2Cr. Okay, 2 Al2O3 plus 2Cr plus it will give out some heat. So it's an exothermic reaction. Exothermic reaction. So here, since Al2O3 is formed, so the reverse reaction is non-spontaneous. So now here the rule is that aluminum acts as a good reducing agent. Aluminum acts as a good reducing agent, and it reduces. So it reduces the oxides. So it reduces the oxides of the metals like chromium, iron, manganese, etc. So it will reduce their oxides to form the respective metals. The respective metals will be formed. And so the reverse reaction is non-spontaneous. So non-spontaneous, it means that here in for the reverse reaction, the delta G naught will be is positive. And for this forward reaction, when aluminum will reduce the oxide of chromium, so this forward reaction is spontaneous. So here for this forward reaction, the delta G naught is negative. So it means the delta G naught for the formation of of Cr2O3 will is obviously higher than that of the delta G naught for the formation of Al2O3. So option C is the correct answer. Since the delta G naught for the formation of Cr2O3 will be positive when it is reacting with Al. When it reacts with Al means on reaction with aluminum, and delta G naught for the formation of Al2O3 will be negative since it is spontaneous when Cr2O3 reacts with Al for this reaction. So hence option C is the correct answer. Then here it is told the oxidation state of iron. The oxidation state of Fe in the brown ring complex FeH2O whole 5, FeH2O whole 5 NO called SO4. So for sulfate ion, it is in -2 state. It is 2 minus, and NO, and the charge of NO and H2O, this will be 0 only, and the charge for sulfate ion, that is 2 minus. So iron should be in 2 plus state. So option B is the correct answer. Then here it is told in the reaction, in the reaction FeSO4 to FeSO4 plus H2SO4 plus H2O2, that gives Fe2SO4 whole thrice plus 2H2O. So here the oxidizing agent is, so here iron is in +2 state, here iron is in +3 state. So here we have oxidation, here iron is oxidized, here we have oxidation, and here H2O2, here oxygen is in -1 state, m- in -1 oxidation state, and here oxygen is in -2 oxidation state. So here there is reduction. So H2O2 itself gets reduced, so it is the oxidizing agent. So it is the oxidizing agent. So H2O2 is the oxidizing agent, and FeSO4 is the reducing agent. Since an oxidizing agent should itself get reduced. So here H2O2, so option C, H2O2 is the oxidizing agent. Here 3ClO minus aqueous gives ClO minus plus 2Cl minus. So here, so it is an example of which type of reaction it is told. So here ClO minus, so here there is no change. Here Cl is in +1 state. Here also Cl is in +1 state. Here Cl is in -1 state. So here there is no change, but here we have uh, here chlorine is reduced. So here there is reduction. So only reduction is there. So option B is the correct answer. So it is only a reduction reaction. Then here it is told the standard reduction potential at 298 Kelvin for the following half cell reaction is this. Okay, which of the following is the strongest reducing agent? The strongest reducing agent, it means that it can more easily get oxidized. So it will more easily get oxidized. So more easily get oxidized means that its reduction potential should be low. It means that its reduction potential should be lower. For stronger reducing agent, it should more easily get oxidized, so its reduction potential should be lower. Reduction potential is lower. So here, as we know that for zinc only, the reduction potential is the least, since why it is in the negative. For zinc, we see that the reduction potential is negative, reduction potential is negative, and so and so it is the strongest reducing agent since its reduction potential value is the least. For zinc, the reduction potential value is the least, and so it is negative, and so it is the strongest reducing agent. So option B is the correct answer. Then here it is told for the redox reaction MnO4 minus plus H2C2O4 plus H plus, that gives Mn2 plus CO2 plus H2O. Then we have to find the values of these coefficients x, y, z, no, x, y, m, and n only. Okay, here, so here we can see that the reaction happens in the acidic medium. It happens in acidic medium. So we have to balance this redox reaction in the acidic medium. So here MnO4 minus goes to Mn2 plus. So here Mn is in +7 state. So here it has to gain 5 electrons, and here there is lesser amount of oxygen, so we have to add H2O. So 4 H2O I should add. And then here we have got lesser amount of H plus ions, so we will add 8 H plus ions. Then C2O4, H2C2O4. So C2O4 2 minus ion will change to CO2, 2 CO2. So then here C2O4 2 minus and 4 to the 8. Okay, 8 minus 2, 6. Okay, here it is in +3 state, +3 oxidation state. Carbon is in +3 oxidation state here, and here it is in +4 oxidation state. So here it means I should add 2 electrons. And here we have to add 2 H plus ions also. Since it will, here it has got 2 hydrogens. So now here we have to add 2 electrons, and here we have to add 5 electrons. So, so this we can multiply with 5, and this we can multiply with 2. And then we can add them. So here it will be 16H plus 2 MnO4 minus plus 10 electron plus 5 H2C2O4 gives 2 Mn2 plus 8 H2O plus 10 CO2 plus 10 electron plus 10 H plus. So the electrons will get cancelled. Here 10 H plus will cancel with 16, so 6 H plus will be there. So the final balanced ionic equation. The final balanced ionic equation will be 2 MnO4 minus plus 5 H2C2O4 plus 6 H plus, that gives 2 Mn2 plus 10 CO2 plus 8 H2O. So here simply we have to balance this ionic equation in the acidic medium. then only we will get. So here it means the value of x is 2 and y is 5 and m is 2 again and n is 10. So 2, 5, 2, 10. So option B is the correct answer. Then here it is told the number of moles of electrons required to reduce 0.2 mole of Cr2O7 2 minus to Cr3 plus. So here Cr3 plus ion will be formed. Here 2 Cr3 plus ion will be formed. So here you have to add here 7 to the 14, 10 minus 2, 12 by 2, so 6. So here chromium is in plus 6 oxidation state and here it is in 3 plus oxidation state. So here 3 electrons it will gain. So 2 chromium atoms it will gain 6 electrons. So it means that 1 mole of Cr2O7 2 minus ions needs 6 moles of electrons. 6 mole of electrons to get reduced to get reduced to 2 moles of Cr3 plus ions. So it means that 0.2 mole of Cr272 minus that requires 0.2 into 6, so 6 to the 12, 1.2 moles of electrons to get reduced to 0.4 moles of Cr3 plus ions. So 1.2 mole of electrons is required. So option A is the correct answer. Then it is told the oxidation number of nitrogen atoms in NH4NO3. NH4NO3 means it is formed from NH4 plus ion and NO3 minus ion. So here it means that hydrogen is in plus 1 state. So H plus, so here suppose the oxidation state of N is nitrogen is X here and here it is Y. So the oxidation state of hydrogen is, it will be plus 1 only. So it will be X plus 4 that is equal to plus 1. So it means that X will be equal to minus 3. And here oxygen is in minus 2 oxidation state. So it will be, here it is Y minus 3 into 2 that will be equal to minus 1. So Y that will be equal to 6 minus 1 that is equal to plus 5. So it is in minus 3 and plus 5 oxidation states. So option A is the correct answer. It is told in which of the following cases a chemical reaction is possible. Chemical reaction is possible in which of the following cases? AgNO3 solution is stirred in a copper spoon with a copper spoon in the first case, in the option A, and in B it is told concentrated HNO3 is stored in a platinum vessel. Then gold ornaments are washed with dilute hydrochloric acid. Here concentrated HNO3 is used, and in D it is zinc sulfate is placed in copper vessel. So here actually we have to use the activity series of metals, activity series of metals. So here, as we know that we have potassium and then sodium, then calcium, magnesium, aluminium, then zinc, then Fe, Sn, then Cu, and here we have hydrogen also. Then after this we have copper, then mercury, then silver, then gold, then platinum. And here the rule is that the metal which comes above which comes higher in the activity series, can displace the lower metal from its salt. Suppose if we react calcium with zinc sulfate, then reaction will happen. It means that it will form calcium sulfate plus zinc. Since calcium is placed higher than zinc, since calcium is more reactive than zinc. But if zinc is reacted with uh, calcium sulfate, then here no reaction will happen since zinc is not zinc can't displace calcium from its salt since zinc is less reactive than calcium. So here silver is lower than copper. So copper can displace silver from its salt. So here reaction will happen. Reaction will occur here. And in concentrated HNO3 with platinum, so here platinum comes below hydrogen. So it means that platinum can't displace hydrogen from any dilute acid. So platinum can't displace hydrogen from any acid. So here no reaction will happen. No reaction will happen here. And here also Au means gold. Gold is also placed lower than hydrogen. So gold is also less reactive than hydrogen. So it will also not be able to displace hydrogen from any dilute acid. So here also no reaction will happen. And here also zinc sulfate plus copper. So copper is placed below zinc. So copper is less reactive than zinc. So copper also can't displace zinc from its salt. So here also no reaction will happen. So the only reaction will happen in the option A. So option A is the correct answer. Then here it is told which of the following is not true for oxidation. So oxidation, we can say here we can have addition of oxygen. It is also oxidation, or we can say addition of an electronegative element. Yeah, that is also oxidation. Since why when oxygen is added or any other electronegative element is added, then the oxidation state of the element will increase. So there will be oxidation. When the oxidation state increases of any element in any kind of chemical reaction, then it will be called as oxidation. And if the oxidation state of any element decreases, then that will be called as reduction. And here we can say removal of hydrogen also. Removal of hydrogen is also oxidation, but removal of electronegative element is not oxidation. Removal of electronegative element will be called as reduction. Since why here oxidation state of the element will decrease. Option D is the correct answer. Then here it is told in which of the following compounds then here it is told in which of the following compounds an element exhibits two different oxidation states. Here we have N2H4 and NH4NO3. So in NH4NO3, as we have seen, in NH4NO3 is made up of two complex ions. One is NH4 plus and NO3 minus ion. So here the oxidation state of nitrogen is -3 and here the oxidation state of nitrogen is +5. So here it is in NH4NO3 only we have two different oxidation states. So option D is the correct answer. Then here it is told which of the following oxoacids of phosphorus can reduce silver nitrate to metallic silver. So the rule is that um, only that oxoacid, only that oxoacid of phosphorus or only that oxyacid of phosphorus which has a pH bond. Which has a pH bond. In it means when if there is a sigma bond in between phosphorus and hyd- hydrogen in any of the oxyacid of phosphorus, only that will be able to reduce silver nitrate or gold nitrate to m- metallic silver or metallic gold. Okay, only that oxyacid of phosphorus which has a pH sigma bond, only that will be able to reduce AgNO3 or AuNO3, silver nitrate or gold nitrate to metallic silver or gold. So that is the rule. So here, so we should know the various structures of the oxyacids of phosphorus. So for H4P2O6, which for H4P2O6, the structure is like this. Okay. So H2, so here also we have one more OH bond. Here also one more OH bond. So H4P2O6, 2, 3, 4, 5, 6, 7. So here we have no pH bond. So it will not be able to reduce the silver nitrate to silver. And similarly, the structure of H3PO4, H3PO4 structure will be like this. Here we have POH whole thrice and open. So it is the structure of H3PO4. So here also we have no pH bond. So it will also not be able to reduce silver nitrate to silver. Then in H3PO2, we have pH bonds. Here we have POH. Here one lone pair is also there on phosphorus. So H3PO2. Or I think that is wrong. Here it will be here one more pH bond is there. Here we have one oxygen. H3PO2. Okay. So here we have two pH bonds. So it means that it can reduce AgNO3. Can reduce silver nitrate AgNO3 to silver. Then we have H4P2O7. So H4P2O7 structure is like this. So here we have H4P2O7 since by 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yeah. So it is the structure of H4P2O7. So here also we have no pH bond. So it can't, here also it can't reduce AgNO3 to silver. So H3PO2 can reduce. So option C is the correct answer. Here it is told that we have to find the coefficients A and Y. So here MnO4 minus ion plus S2O3 2 minus ion plus S2O3 2 minus ion plus H2O gives MnO2 plus SO4 2 minus plus OH minus. So here simply it means that it should be balanced in the basic m- medium. So we have to balance it in the basic medium. Since here OH minus has been used, the hydroxyl ion has been used. So in basic medium, if we have to balance it, then as we know, MnO4 minus ion will change into MnO2. Here Mn is in 4 to the 8, so it's plus 7 oxidation state. And here Mn is in plus 4 oxidation state. 2 to the 4, yeah. So here it needs 3 electrons. It has to gain three electrons to get reduced to MnO2. And here, since we have lesser amount of oxygen, so here we have to add 2 hydroxide ions. Here we have to add 2 hydroxide ions since we need 2 oxygen atoms. And here also hydrogen is not there here. So we should add H2O here. Now here we have, okay, now here we have 5 oxygens and here we have 4 oxygens. So actually the thing is that here we have to add Z. Okay. We have to add Z number of OH minus ions. And then in S2O3 2 minus also. So here actually, let's say we have to add m number of OH minus ions. So here we need m. So here we have 2 plus m number of oxygens, and here we have um, 4 oxygens. So we need 4 plus here m minus 2 hydrogens. So we have 4 plus m minus 2. So yeah, so here also the number of oxygen atoms should be same. So it should be m minus 2. Okay. M oxygens, m plus 2 here, 4. And here the number of hydrogen atoms also should be same. So therefore here the number of hydrogen atoms is m minus 2 into 2. That should be equal to m. So therefore m, the value of m we have to find. So 2m minus 2, sorry, 2m minus 4, that is equal to m. So m equals to 4. So this should be 4. This should be 4 and 4 minus 2, that should be equal to 2. Now it is balanced. Now it is balanced. So it means here we should have 4 hydroxide ions and here 2 H2O. Okay, so now S2O3 2 minus ion, that will be reduced, sorry, that will be oxidized to SO4 2 minus. Since here sulfur is in 3 to the 6 H minus 2, 4, 4 by 2, that is plus 2. Here it is in plus 2 oxidation state, and here it is in 4 to the 8, 6, 6 minus 2, 4. 4 by 2, that is plus 2. Okay, here 4 to the 8, 8 minus 2, that is plus 6. So here sulfur is in plus 6 oxidation state. So here it should form two sulfate ions. So here it should gain. So each sulfur ion has to lose. Each sulfur atom will lose 4 electrons. So two of them will lose 8 electrons. 8 electrons. Plus 2 goes to plus 6. And here we have 8 oxygens, and here we have 3 oxygens. So here we need hydroxide ions. Let's say we take n number of hydroxide ions. So here also we need some amount of H2O. So here also the number of oxygen atoms should be same. So here it is n plus 3, and here also it is 8 plus n minus 5. So this should be n minus 5. And the number of hydrogen atoms also should be same. So it is n minus 5 into 2, that should be equal to n. Therefore, 2n minus 10, that is equal to n. So n should be equal to 10. So this should be 10 and this should be 5. Now we can add them. Now we can add these two equations. No, actually here we have 8 electrons and here we have 3 electrons. So we have to make the number of electrons same. So this we have to multiply with 8 and this we have to multiply with 3. And then we have to add them. So then it will come. So 8 to the 16 H2O plus 8 MnO4 minus ion, that will give 8 MnO2 plus 4 is a 32 hydroxide ions. And here we have 3 tens 30, 30 OH minus plus 3 S2O3 2 minus. And here also I will have 3 to the 6, 6 SO4 2 minus plus 15 H2O. So the final balanced ionic equation, the final balanced ionic equation is, so here 15 H2O will cancel with 16 H2O. So this will be 30 OH, that will cancel with this. So it will be 2 hydroxide ion only. So it will form 8 MnO4 minus plus 3 S2O3 2 minus plus H2O, that will give 8 MnO2 plus 6 SO4 2 minus plus 2 OH minus. So here, therefore, the value of A is 8, and the value of here V2, here it was A, and Y is here. Y is the coefficient of sulfate, so Y is 6. So 8 and 6. So option D is the correct answer. Then here it is told the reducing agent in the given equations is. So here in the first equation, as you can see, that here silver is in oxidation state 0. And here also oxygen is in oxidation state 0. Here silver is in this. For cyanide, the charge is -1 only. Here also it is in -1 charge only. So the oxidation state of silver is +1 here. So here we have oxidation. So silver is getting oxidized. So here we have oxidation. And here hydroxide, here oxygen is in -1 oxidation state. So here there is reduction. Here there is reduction. So the reducing agent should get oxidized. Reducing agent should itself get oxidized. Here AgCN2 minus, here silver is in +1 oxidation state, here silver is in 0 oxidation state, here zinc is in 0 oxidation state, but here zinc is in +2 oxidation state. Since the charge for Cn is -1, so Cn4 charge, the net charge is -4, but for the complex ion, the net charge is -2, so zinc should be in +2 oxidation state. So here we have oxidation, and here silver has been reduced. So here there is reduction. So here the reducing agent has been asked. So reducing agent, it means itself it should get reduced. So here silver gets reduced. Silver gets reduced from +1 state. So the reducing agent should itself get oxidized. Reducing agent should itself get oxidized. Here silver gets reduced from +1 to 0, and zinc gets oxidized. Zinc gets oxidized from 0 to +2. So zinc is the reducing agent. Since why it itself gets oxidized. So option C is the correct answer. And here it is told, what is the oxidation state of sulfur in H2S2O8? So the structure of H2S2O8, which is also called Marshall's acid. So it is like this structure. Here we have a peroxide linkage. We have a peroxide linkage here. So H2S2 and O8, since 1, 2, 3, 1, 2, 3, 6 plus 2, 8. Huh? So here we have a peroxide linkage. Peroxide linkage. So it means so this oxygen is in -2 oxidation state. Oxygen is always in -2 oxidation state, but here hydrogen is in +1. So this entire hydroxide OH is in -1 charge, and here each oxygen atom is in -1 charge since it is a peroxide linkage. So means that the charge for sulfur should be 2 plus 2, 4, 4 plus 2, 6. So it is in +6 oxidation state. Here also it is in +6 oxidation state. So here the oxidation number of sulfur is +6 here. So option B is the correct answer. Then in the ionic equation, BiO3 minus plus 6H plus X number of electrons goes to Bi3 plus 3H2O. The value of X is. So here Bi is in 3 to the 6, 6 minus 1 in +5 oxidation state. So it means that it has to gain, it has to gain 2 electrons to form Bi to get reduced to Bi3 plus. And here it has been balanced in the acidic medium, since why here H plus has been used. And here hydrogen, the number of hydrogen atoms is same here on both the sides, and the number of oxygen atoms is also same on both the sides. So in acidic medium, only we have to balance this ionic equation, and so 2 electrons is required to reduce this BiO3 minus to Bi3 plus. So X, the value of X will be 2. So option 3 is the correct answer. Then here it is told that the hydroxyl ion concentration of 1 molar HCl is how much? So 1 molar HCl, it means that the concentration of H plus is 1 molar, means the concentration of hydronium ion. And we know that at 25 degrees Celsius, the value of Kw, which is the the equilibrium constant for H2O, or the dissociation constant of H2O. Now that is given as concentration of H plus into concentration of hydroxyl ion, that is equals to 10 power minus 14. So therefore, here the concentration of hydroxyl ion into the concentration of H plus, that is 1, that is equal to 10 power minus 14. So hydroxyl ion concentration is 10 power minus 14 only. Or I can say 1 into 10 power minus 14 molar. Molar means I can tell mole per liter also, and 1 liter is same as 1 decimeter cube. So we can say it as 1 into 10 power minus 14 mole per decimeter cube. So option 1 is the correct answer. Then here it is told the oxidation state of iron in K4 efficient 6 is, in K4 efficient 6, the oxidation state of iron is. So here potassium is in K in +1 oxidation state, and here Cn is in -1 oxidation state. So it means here the net charge for FeCN6 complex ion, it is -4, it is 4 minus. So it means the charge of Fe should be in +2. So Fe is in +2 oxidation state. Since Cn, the charge on cyanide ion is always -1. So -6 plus 2, that only will give us -4. So iron is in +2 oxidation state. So option 1 is the correct answer. Then here it is told in the conversion of Br2 to BrO3, the oxidation number of Br changes from. So in Br2, the oxidation state of Br is 0 only, since it is in the free molecular state, it is in the free state. And here in BrO3 minus, the oxidation state of Br is 3 to the 6 minus 1, so it is in +5. Since the oxidation state of oxygen is always -2. So 3 to the 6, 6 minus 1, that is +5. So the oxidation state, the oxidation number of bromine changes. Bromine changes from 0 to +5. So option 1 is the correct answer. Then here it is told the formula mass of Morse salt. The formula mass of Morse salt is 392. Then the and here iron is present in it. So it is oxidized by KMnO4 in the acidic medium. So in Morse salt, as we know, here iron is in +2 oxidation state. So it will be oxidized to Fe3 plus ion in the presence of KMnO4 in the acidic medium. So here MnO4 minus ion will change into Mn2 plus ion. So it will gain 5 electrons, since here Mn is in +7 oxidation state. So here Fe2 plus will lose 1 electron only. And therefore we have to find the equivalent mass of Morse salt. Now equivalent mass, we know that is equal to molar mass divided by the valency factor or the n factor. Now the valency factor, that is equal to the number of electrons that is lost or gained by one molecule, or one ion. So here one Fe2 plus ion, or one molecule of the Morse salt, that has to gain 1 electron only, so that the iron in it gets oxidized from +2 state to +3 oxidation state. So therefore the valency factor for Morse salt, in the acidic medium is 1 only. So therefore the equivalent mass of Morse salt will be same as the molar mass or the formula mass of Morse salt. So here actually the we can tell it is molar mass by valency factor, or we can say the valency factor times the formula mass. Formula mass. So okay, no, sorry. Here the molar mass is only called as the formula mass only, since the molar mass is a solid crystalline salt. It is a crystalline salt, so it is the molar mass is also called as formula mass, or it is also called formula mass. So here the equivalent mass will be same as the molar mass or the formula mass. So since the valency factor of more salt is 1, since it has to lose, it will lose 1 electron only. So therefore the equivalent mass will be also 392. So option 1 is the correct answer. Then it is told among the halogens, the one which is oxidized by nitric acid is. So nitric acid HNO3, that will oxidize uh, will oxidize iodine into IO3. So it will form HiO3 and NO2. So 2 HiO3, 2 NO2 and H2. Oh, 2 HiO3, okay. 2 HiO3 and NO2 will be formed. Good. So it will oxidize iodine only. So option 4 is the correct answer. Then it is told the metal which does not form ammonium nitrate by reaction with dilute nitric acid. So here the question is actually wrong slightly. It should be told the metal which does not form its nitrate. The metal which does not form its nitrate by reaction with dilute nitric acid is. So here nitric acid, when HNO3 reacts with Mg, then it will form magnesium nitrate and hydrogen. Since why, here also we have to use the activity series of metals, activity series of metals. So we know that MgAl and Fe are above hydrogen. Then lead is also above hydrogen. Yeah, but here lead is just above hydrogen, or no, lead will be below hydrogen. So lead is above hydrogen only, but uh, so it means these metals are highly reactive, so they can easily they can displace hydrogen from dilute acids. They can easily displace hydrogen from dilute acids, but here lead is only just above hydrogen, so it can't easily displace hydrogen from dilute acids. So hence with Mg, magnesium nitrate and hydrogen will be formed, and with aluminium also, aluminium nitrate will be formed, Al2NO3, sorry, AlNO3 all thrice. And with iron also, Fe means iron nitrate will be formed. And with lead, nitrate is not formed. and with lead nitrate will not be formed. So since why here PbO with NO2 will be formed plus O2. So here lead nitrate is not formed. Since why when lead nitrate is formed, PbNO3 when it is formed, so then it is uh, so it is very unstable. So it can easily it easily decomposes into lead oxide and nitrogen dioxide. So hope all of you understood the solutions of all these questions based on the previous year KCT exam on the chapter Redox Reactions. Still, any doubts if you have, then please write that in the comments section. We shall obviously clarify them in the subsequent videos. Um, Also, please install our Sapience Education application where we shall upload some more important homework questions which are based on the previous year KCT exam on every chapter of chemistry. So please install our Sapiens Education application. Okay. So thank you, everyone. Bye.